Hello, this is the lecture on resource pools. We will describe resource allocation settings for CPU and memories. We will discuss creating resource pools, how to set resource pool attributes, and we will describe expandable reservations. What is a resource pool? Well, as the slide says, it's a logical abstraction for hierarchically managing CPU and memory resources. It's a construct that allows you to collect resources, RAM, the physical RAM, the physical CPU, and manage them from a central point. So you can have, like in this example, you can collect several virtual machines. In this case, we have our Prado 3-1, -2, 4-2, and 4-3, and we collect the four of them together, and we manage those limits, reservations, and shares that we spoke about in the last lecture from a higher level, from a central point. Rather than managing them individually on the virtual machines, we can do it at the resource pool level. And resource pools can actually have nested pools as well. So those limits and those reservations can be applied at the parent resource pool, and then those will propagate down to or be shared amongst the child resource pools. And by default, that actually always happens. There's a root resource pool that is the ESXi host itself. So every ESXi host that you have is in and of itself a resource pool. It's represented just as an ESXi host because there's no reason to represent it as a resource pool. It's a different entity, but it does act as a root resource pool. Resource pools can be used on a standalone ESXi hosts, or they can also be used within a vSphere or a vCenter environment using distributed resource scheduler, or just even within vCenter without doing any high availability or resource scheduling or anything like that. There's another resource pool that we will talk about another time called vApp. And so vApps actually are resource pools. They're expanded resource pools, and in a vCenter environment, which is where only place you would use vApps, they have an expanded functionality or extended functionality from a resource pool. But if you created a vApp and then you went and managed that host directly, so if you had a vCenter environment set up, you set up a vApp, and then for some reason you connect directly to an ESXi host with your vSphere client outside of the vCenter environment, then since vApps are not a construct of a standalone host, it would actually show up as a resource pool when you connect to it and not as a vApp. Just an interesting factoid for you. So why use resource pools? Well, they are flexible. You can add, remove, reorganize resources as needed. You can adjust the shares, and rather than having to do that individually at every single machine, you can do it at a higher level. You have a development pool, maybe you have a production pool, or maybe those pools you actually set up by different departments or different customers that you have. And that kind of gets into that last one on their managements of sets of virtual machines running a multi-tier service. And the idea behind that is that maybe you're an ASP or you work for a company that's providing infrastructure in the cloud out to several different clients, and depending on their service level agreements, how much they pay a month and what their contract says, you may have one customer who pays a lot more and they have a higher availability or higher access to resources, and so you may create a resource pool for them and give it higher, maybe set a reservation for it. Maybe the SLA says that these particular machines will always have at least 1 gigahertz of processor available. So that would be something you could do for their entire group of machines. You could create a resource pool for that customer and then set a reservation of 1 gigahertz or whatever it is. Same thing for memory. You could set those limits at that level for the whole entire customer, and then they build however virtual machines they need. But within their group, you're guaranteeing them a specific amount. And then the shares, again, would be based on priority. So if this customer pays more, they have a higher SLA, you may give them a higher priority than somebody who's paying less, and so you would give them a greater number of shares than the other person. If we go back up to isolation, so isolation and sharing, the vSphere administrator can make a pool of resources available to department admins, and then they can use that as needed. So kind of the same idea, or a similar idea at least, to providing to customers. Maybe like internally, pardon me, internally you might want to give the maybe the finance department more resources than the R&D department, or vice versa. And you can just kind of set that up ahead of time and say, okay, well, we've got 12 gigahertz of processor available. I'm going to give the R&D folks 4 gigahertz of that, and they can do with it what they wish because they admin their own stuff. But at a higher level, obviously, one person or one group needs to control the the infrastructure. So of 12 gigahertz of processor, we're going to let development or the R&D folks have 4 gigahertz, and then the balance of that, the other 8 gigahertz, is going to be given off to finance for production or something. And so you can do that with the resource pools there. Access control. So it's not just about setting up the different reservations and limits or shares, but also if you want to group a bunch of machines together and set permissions based on that resource pool. Now, if that's the only reason why you were doing it, you might not necessarily use a resource pool. You might just choose a folder because, again, you'll recall that you can set permissions based on folders as well. But no need to have a folder and a resource pool if you were going to do some resource, some limits or some reservations. Then you might as well just go ahead and do that, and then you can set permissions on top of that as well. And then separation from hardware, what that means is when you look at a DRS cluster, so once you cluster a bunch of virtual machines together, rather than having to worry about the individual resources from each of those ESXi hosts. So let's say we had 2 hosts, and each host had a total of 12 gigahertz of processor in it. Rather than looking at, okay, I have 12 gigahertz here and I have 12 gigahertz on this other host, we just lump it all together into one resource pool. Just by default, as soon as you create a DRS cluster, that cluster itself becomes a resource pool. And so it lumps everything together. So rather than looking at it as 12 and 12, it just looks at it as 24 gigahertz, and you just spread it across them. And when we talk about DRS more, you'll see how kind of it does load balancing, and it makes sense that everything's managed at that level. So the cluster becomes a resource pool, and then you could create different resource pools underneath that cluster. So here are resource pool attributes, and this is how we would actually set these shares, reservations, and limits on different resource pools. Now, so built in, there's low, normal, high, and custom. And you say, well, what the heck is low and normal? Again, it's relative. So, low would be less than normal, normal would be right in the middle, and high would be greater than normal and low. And so that gives you right out of the gate 3 different priorities that you can set. And then custom would be you would actually specify the number. And the examples we've talked about so far have been actual numbers. But just know that you can also actually, if you cared about 3 different levels, you could do low, normal, and high. And it doesn't really matter what those numbers are because, again, it's fairly arbitrary. It's just that you need to know what the total number of shares that could be made available or are currently available, and then you can base it on that. And again, the reservations would be in megahertz for the CPU and in megabytes for the memory resources. And again, you can set the limits. That's just how much total this particular resource pool can use. That's the maximum that would be allowed to be used. And then you can set unlimited as well if you just want to make it go forever. That other checkbox that we just passed over, expandable reservation, that will allow if you set a reservation to a particular point, it'll allow it to go over the limit. So it should be expandable limit, not necessarily reservation, but it allows the pool or a virtual machine to draw from its parent if it needs more. And we'll actually see an example here in a second on that. So if the box is checked yes, then it will allow subpools to draw from it. If this is a resource pool and you have subpools, it'll allow virtual machines or subpools of this given resource to increase their limits by taking resources from it. That'll make sense in a second. So let's look at an example. In a couple of slides, we'll look at the actual specifics of that expandable reservation. But first, we're just going to look at the resource pool in general. In this particular example, we have an IT department that has two internal customers, finance and engineering. Finance pays for 2/3 of the budget, and engineering pays for 1/3. So we can assume that, maybe not rightfully so, but for this example, we're going to assume since finance pays for 2/3, they're going to get 2/3 of the resources. And since engineering only pays for 1/3, they're only going to get 1/3 of the actual resources. Each one of those departments or customers, finance and engineering, have production and a test or dev environment. And so let's see how that plays out. So for the engineering pool, we have a standalone host that has 12 gigs of memory, or I'm sorry, 12 gigs of CPU and 4 gigs of memory. In the engineering pool, we're going to set up CPU shares of 1,000. Again, arbitrary. What does that 1,000 shares of CPU mean in this particular slide? Absolutely nothing, because there's nothing to relate it to. A single pool by itself assigning the CPU shares, again, it's relative to the siblings. In this case, there are no siblings yet. We'll see in a second. But the reservation of 1,000 megahertz does mean something. We can't add this engineering pool unless there was 1,000 megahertz of CPU available. Limit is 4,000, so it'll never use more than 4,000, and the expandable reservation is set to yes. So virtual machines that are in this particular engineering pool can draw from its reservation or from its reservation to get some more resources should they reach their limits as well. And so this particular pool has 2 VMs in it, a test VM and a production VM. Each one of them, the test VM has 1,000 CPU shares and the production has 2,000 CPU shares. So the production one has twice as many shares as the test, and that makes sense. Production needs to have priority, so production will have priority in this particular case. The test VM has no reservation on CPU speed, but the production one does. If there is not 250 megahertz of processor available, then the production VM will not start. And then they both have a limit of 4,000 megahertz, 4 gigahertz. That's the most that they could take. In this particular example, if this is all we had on this machine, some of these reservations and limits, well, the reservations might make sense, but the limits don't necessarily make sense because we have 4 and 4. So if each of these guys got to use their entire 4 gigs of CPU, we have 12 gigs total on this host. So why are we setting those limits? But then if you look, you have your 4 and 4, that's a total of 8 gigahertz. We don't have 8 gigahertz available in the engineering pool above it, do we? But we have expandable reservation set to yes, so that will actually expand to 8. If it was set to no, then it wouldn't. There'd be some contention there. Again, we'll play this out in a second here. All right, so here's a better example. This kind of fits the example we talked about. We had an engineering and a finance department. Again, as I said, the finance pool pays more, so they get more. In this case, there's a total of 3,000 shares here. Finance pays for 2/3, engineering pays for 1/3. So 2,000 out of 3,000 is 2/3. 1,000 out of 3,000, 1/3. So that kind of plays out there, right? Engineering pool has 1/3 of the actual resources. Finance pool has 2/3 of the actual resources. And then we see the limits down below with the actual virtual machines are similar to the previous slide. We're giving, in both cases, we're giving test 1,000 shares and production 2,000 shares. So in both cases, the test VM has 1/3 and the production has 2/3, but that 1/3 of the engineering is less total than the 1/3 of the finance, because we're talking about 1/3 of 1,000 versus 1/3 of 2,000. Stay with me. We'll look at it right here. Okay, so we have if we equate percentages to the shares, again, we're looking at a total of 100%, right? If we take 100%, and again, 1,000 of 3,000, because you have your 1,000 in engineering and your 2,000 in finance, total of 3,000. So 1,000 of 3,000 is 1/3. So a third of 100% is 33%. Now, if we look over at the finance pool, that's 2,000 out of 3,000, or 2/3 of 100% is 66.6 or whatever, 67%. I don't know why there's a dash there. That's not a minus, that's the dash. I should clean this slide up. So engineering pool has 33% of the CPU, and finance has 67% of the CPU. Then if we look at what does that mean to the actual virtual machine? So if the test VM under the engineering pool on the far left there has 1,000 shares, 1,000 shares, or I'm sorry, 1,000 shares, and the production engineering machine has 2,000 shares. Again, 3,000 shares down there, and so that test engineering VM has 1/3 of 1,000 shares. Looking up at the top, so 1/3 of 33%. If the entire total at the very, very top here, if up here at the very, very top, we're talking 100%. So 33% of this 100% is available for these two guys. So we have to divide this 33% amongst these guys. Well, if this test engineering VM gets 1/3 of whatever this is, 1/3 of 33 is 11%. This guy gets 2/3. So 2/3 of 33% is 22%. So if we're breaking these guys down, what are these relative percentages of the entire 100% of the CPU? 11% and 22%, respectively. And if we look at the finance pool, we have 67% of the total 100 here. So what is, again, we have 1,000 and 2,000, so this is a total of 3,000 between these two guys. It's the same relations that are over there. So the test machine gets 1/3 of 67%, though, not 1/3 of 33, because over here we have our 2,000. This gets to 2/3 of 100, which again is 67%. So 67% here, 1/3 of 67% is 22%, right? If you have this 2,000 over here, so 2,000 out of 3,000 is 2/3. 2/3 of 67% is 44 or 45, whatever you want to break it down. So 44%. So 22, 44, that should equal 67, 66 if you're doing the math correctly. Over here, 1/3 of 33 is 11, and 2/3 of 33 is 22. So 11% and 22% is 33%. Over here, your 22 and your 45 is 66. 66 and 33 is close enough to 100. We can talk about it again in class if we need to. And I'm saying a lot of numbers. All right, so let's talk more about expandable reservations and how this all works out. Expandable reservation is really just borrowing the resources from the parent. And as the slide mentions, this borrowing happens recursively as long as the reservation is set for expandable. So what that means is it happens recursively going up through the parent. So if you had nested pools, or even at the very bottom you had the actual virtual machine, if the virtual machine, this is assuming all the reservations are set for expandable. If the virtual machine is set for expandable, or I'm sorry, if the pool above, if the parent pool above virtual machine is set for expandable, and the virtual machine needs more resources, then that pool will let that virtual machine get those resources from it. Now, if that pool doesn't have enough resources, it needs to borrow from its parent. And so if its parent has expandable reservation enabled, then it will go borrow from its parent. If that parent doesn't have enough to support that reservation, and assuming its parent has expandable reservation set to yes, then it can borrow from its parent. So that's the recursion, the reverse. It's going up the tree instead of down in this particular case. So what's good to note here? Well, the big orange thing there, yellow thing there in the middle is telling us that mismanaged or missized expandable reservations can claim all unreserved capacity. So it would essentially just nullify the point of even having reservations in the first place. If you set up all these reservations or all these limits and then you just allow everything to be expandable, well, then it's just going, whoever needs it's going to get it first. It's just going to recurse all the way back up to the very top. The root resource pool, again, is the cluster or the host itself. If everything's set to yes, then there's really no reason to set the limit, because it's just going to recurse all the way up to the top and gobble up all of the resources until whoever first come first serve at that point. So look at a couple examples here. In this case, let's look down at the right-hand side. The e-commerce web pool has a reservation of 1000 megahertz, and the reservation is not expandable. So that means any virtual machines or even resource pools nested under that that e-commerce web pool will not be able to use any more than 1000 megahertz. So if I have VM1 is on and running at 400 megahertz, and VM2 is on and it has a reservation of 400 megahertz, and VM2 has a reservation of 300 megahertz. That's 700 megahertz total. I'm still within my reservation, so everything's good, but I only have 300 megahertz left, right? Because 400 plus 300 is 700, and 1000 minus 700 gives us 300 for a balance. So I could only power on a virtual machine now that had 300 megahertz of reservation. So VM3 there, if we see in yellow, has a reservation of 500 megahertz. Will I be able to power on that VM3? No, I will not. Because it has a reservation of 500 megahertz, I only have 300 megahertz available. It's not going to be allowed to be powered on. So how could we fix that? Well, we could lower that reservation on VM3 to 300 megahertz and allow it to get in. We could turn on expandable reservation on that e-commerce web pool, and that would allow it to gobble up some more resources. So then it would take that, we'll see in a second what that's going to do to it. Or we could increase the e-commerce pool's reservation in the first place. So if we bumped that one up to 1200 megahertz, then we'd have enough for the entire thing without setting it to expandable. Okay, so in this particular slide, we've done two things, and we'll talk through two different examples. Number one, we've set the e-commerce web pool reservation to expandable to yes, and we also set the expandable reservation for the retail pool. So for the first thing we're going to talk through, all we have to focus on is the fact that we set the e-commerce web pool expandable to yes. And so we've got that 300 and 400 again reservation, that's 700 total, and if I want to power on that, so 700 total, if I want to power on that or add that third virtual machine at 500 megahertz, that makes my total 1200 megahertz, right? Well, I have expandable reservation turned on, so it's going to, the e-commerce web pool is going to allow that third virtual machine to be powered on. The problem is, though, that e-commerce web pool doesn't have or didn't have a reservation of 1200. It had a reservation of only 1000. So it itself doesn't have the capacity to provide that 1200 megahertz. Now, if the retail pool above it, the parent pool to that web pool, if it didn't have expandable reservation turned on, we'd be dead in the water. The web commerce pool would say, oh yeah, you can borrow some processor from me, but if it doesn't have the processor to give, then it's just going to fail. So the web pool would have reached out to its parent and said, hey, can I get this? And if expandable reservation on the retail pool was set to no, then it wouldn't have happened. It wouldn't have worked. But in this case, expandable reservation on the retail pool is set to yes. So what happens is third VM powers on. It says, hey, I need a reservation of 500. Can you provide that? The web commerce pool says, yeah, I'll let you do that. I have my thing set to expandable, so I'll let you get some of this. And then it goes, oh, wait, I don't have that. So then it reaches out to its parent, the retail pool, and it says, hey, can I get some extra processor here? And since it's set to yes, then it does provide that extra power to it. So it provides that extra 200 megahertz. And in this case, we have a reservation on the other side for the apps pool set to 1200 as well. So that's a total of 2400. And the reservation on the retail pool is 3000. So the retail pool is still cool. It's still gravy. It doesn't need to go get anything from its parent because it was given a 3000 megahertz reservation. And right now it's only serving up 2400. So it doesn't need to actually recurse up any higher. All right, so then we power on some more virtual machines on this apps pool. Originally, let's go back so you can see where we were. We were at 1200, right? So I'm going to power on 4 virtual machines. Each one has a reservation of 500 megahertz. And if we do some simple math, 500 times 4 is 2000 megahertz. And remember, the pool initially only had 1200 for reservation, but expandable is set to yes. So it's going to reach out. So the apps pool is going to look up to the retail pool and say, hey, can I get some more processor because I need another 2000? Well, remember the retail pool had a reservation set in for itself of only 3000. So the apps pool is going to tell its virtual machines, yeah, let me see if I can go get this for you because Expandable was set to yes. It's going to reach out to the retail pool and say, hey, do you have some extra processor for me? And it's going to look and say, ooh, actually, I'm 200 megahertz short. Let me see if I can go get some from my parent. So then it reaches out to the parent and grabs it from the parent. In this particular case, expand reservation is set to yes, and I can assume in this particular case the root resource pool, it is the root resource pool, so that is a cluster or an actual host. So it's going to get that reservation, and everything is happy here. We have our 4 virtual machines powered on the apps pool, and our 3 virtual machines powered on down in the web pool. So you can see how if everything is set to yes, you can easily consume all your resources because everybody's just being free with their resources, just saying, yeah, take it, go ahead. And then so at that point it becomes first come, first serve. Whoever gets there first gets it because we're just handing it out essentially. All right, so admission control. How does admission control work for CPU and memory? How do we allow a resource pool to be created, or how do we allow a virtual machine to be powered on? Or how do we actually allow a pool's reservation to be increased? So that's what that admission control is. That it's kind of a confusing word sometimes, but admission control is what allows a virtual machine to be powered on. Admission control is what allows a pool to be created or a subpool to be created. It's also what allows the reservations to be increased. And admission control actually does some other things as well, and we talk about adding hosts and whatnot. But for this particular example, we're looking at powering on a virtual machine, creating a pool or a subpool, or increasing a pool's reservation. And so the first thing that happens is the environment asks itself, can this pool, this parent pool, satisfy this reservation? If yes, then whatever, go ahead, power on the virtual machine. Go ahead and create that that new subpool it's asking for a particular reservation, or go ahead and increase a pool's reservation because the parent can handle it. There's enough within its reservations, within its limits to handle this. If it can't, then is the reservation set to expandable? And if it is, then yes, go ahead and go to the parent. And then once you go to the parent, you kind of start recursing back up again. Can this parent satisfy the reservation? If yes, no, then you kind of just follow the tree around. But then, ultimately, if it cannot support the reservation or satisfy the reservation, and it is not set for expandable, then as I said, it fails and it won't allow that to happen. So admission is denied. Admission denied meaning then that the virtual machine is not allowed to be powered on, or if you're trying to create a new subpool, it's not allowed to create that subpool, or you're not allowed to increase the pool's reservation in that particular case. Here's just an example or a screenshot here for you showing the summary tab. And just like with a host with a virtual machine, if you go to the summary tab, you can see how much host memory is consumed, the guest memory, resource settings, all kinds of fun stuff. It's just to kind of point out that, the similar graphs are available, similar numbers you can view for the resource pools themselves. So again, we're just clicking on the resource pool here and click on the summary tab, and you can view all sorts of information about it. If you click on the resource allocation tab, a couple tabs over there, then you can again see CPU, memory, and storage. And within that, you can actually, within that particular view, you can see which virtual machines are using which resources, and you can see their settings as well. In this particular case, we can see we're looking at CPU, and we can look at the reservation, the limit, the shares, the value of those shares, which again, it's grayed out and it's arbitrary because they picked normal. The percentage of the shares that particular machine is using. So in this case, shares for 50-50 on this one, then I can tell that there's actually only 2 virtual machines in this particular resource pool because it's half and half, right? Another thing that's pretty cool about that's one more advanced features is you can schedule the resource so you can schedule changes to the resource settings. And what that allows us to do, as you can see on the screen here, is you can adjust shares, reservations, or limits, and you can do that by time. So maybe end of day, office workers are shutting down, going home for the day. Any of the basic application servers, email, maybe those kinds of things may start relinquishing some of their reservations, their limits, their shares, and giving priority to some of the things, maybe the website, e-commerce, things that would happen after hours, any day-in processes that need to occur. Maybe those servers now all of a sudden get higher shares or greater reservations or lower limits, and you can kind of start offsetting some of those. Or that's the wonderful thing about virtualization, is you can dynamically reassign resources and use different resources in different ways without having to physically change processors out. So end of the day, you let the email server, the Exchange server, the SharePoint server kind of ramp down a little bit, and those that support the general business day type applications, and then you can let some of the end of day and the nightly processes, maybe your backup servers, have more of those resources available to them. Or maybe end of quarter, if you're trying to some of the financial applications towards the end of the quarter, the end of the year, or seasonal, maybe in December, November, December, when Christmas time is ramping up, you want to give your e-commerce servers more horsepower. So that's all done through scheduling the tasks. So you can schedule the changes to the resource settings themselves. All right, so now you should be able to describe resource allocation settings for CPU and memory. You hopefully can create a resource pool. You'll do that in the lab. You should be able to set resource pool attributes and describe what expandable reservations are.